thanks everyone. Yet another talk. There's a lot going on today, isn't there? It's just from one thing to another. This one is on Pyrsia. So, quick show of hands. Who has heard of Pyrsia before? Yeah, there we go. Okay, cool. So, trusted open source artifacts on the blockchain. Hands-on introduction by me. So first of all, who am I? Now I've got two photos up there. Frankly, because I haven't got round to updating all of the Slacks and all of the different things. So that's my face, and then if you find me on Slack, I'm the guy scuba diving. Work and advocacy. I am a CD Foundation and CNCF ambassador. I have an observability background, so I'm a DevRel at a company called Dynatrace. I obviously have an observability background primarily, with a bit of security thrown in there, and obviously, as you can see from the T-shirt, progressive delivery, continuous delivery is a real interest of mine as well. So any of those topics, feel free to come and grab me in the hall and speak to me. Outside work, of course, you might have guessed from the photo, I love all things scuba diving, anything about the ocean. If it's got the sea or a boat involved in it, get me there. Although those mountains over there do look pretty good for skiing. So, by the end of today, what will we do? You'll hear about what Pyrsia is, where does it fit in the life cycle and all of the other tools, because all morning I've been hearing about tools and capabilities, so where does Pyrsia actually fit in? Why is it actually necessary in the first place? Why do we need another thing? Talk a little bit about trust, or a lack thereof. Trust, and I'll talk about why that's important. I'm actually going to show you Pyrsia in action, and then I'm going to show you how and where you can experiment with Pyrsia as well. So what is Pyrsia? Apart from being one of the newest projects into the CD Foundation, it is a decentralized package network. And I know some of the talks I've been to this morning have been leaving the screens on not long enough. So if you want screenshots or photos, I'll try and leave these on a little bit longer. But what is a decentralized package network? It's useful to think of it where it fits into the life cycle. So we're not thinking delivery life cycle here, we're thinking developer workflow. And I'm never going to win any awards for my slides, but here is an actor developing some software. He, she, they build a container image and then push it to a container registry. And then obviously I'm abstracting a lot here, but ultimately that gets running in production. So where does Pyrsia fit into this flow? And why? Well, as you've heard all morning and will continue to hear the rest of the afternoon and tomorrow, there's a myriad of different tools. The SAST, IAST, DAST tools, there's quality gate tools within the pipeline like Captain. There are SBOMs and IBOMs and AppSec tools that run all the way right in production. So that's things like continuous scanning of what's going on at a trace level and runtime blocking. So yeah, where does Pyrsia fit in? Logically, Pyrsia is fitting into this container registry part here. So why does Pyrsia need to exist in the first place? Why another tool? Well, this actually is Google Chrome's advice to new would-be Chromium developers. And this is all about trust. So they call it the rule of two. The code which processes untrustworthy inputs, code which is written in an unsafe language, and then code which runs with no sandbox. And they've actually, that isn't me writing that they have written doom, do not do this if you pick more than two. So trust at the boundaries of what you control is critical. That's really what I want you to take away from this and the next diagram, which is OWASP's sort of similar diagram talking about trust boundaries. Now here they're talking about an application and where data flows from one part of an application to another. You need to understand your trust boundaries and where they live. So let's have a look at conceptually what Pyrsia does. Well, what happens if the container registry changes something? I'm not picking on Docker Hub here, but whether you're running on premise, you're paying for service. If they change something, if you hit rate limiting, whatever the case might be, that there's just something that you aren't comfortable with in that registry. What happens if the registry or the repository, if it's NPM, for example, just goes down for a day or two? How many of you, actually, just a quick show of hands, how many of you are pushing to multiple container registries? No one. Maybe? Kind of? Okay. So so we've all got a single point of failure, and our entire software lives say don't have a single point of failure. It's a bit of a contradiction, but anyway. Also, we're assuming that that's you, or that's the person you trust. If you're depending upon Nginx or some package, let's say, that might not be you. How many of you are, every time you build a new version, you're continuously pushing the old versions as well? Because if someone gets into your container registry, what then? So there's all sorts of cases where Pyrsia comes into it. So how does Pyrsia actually help? Well, Pyrsia says, okay, you've got a container registry, but I don't really care about that. I'm going to go to the source of truth, Git, and I'm going to build it for myself. Then I'm going to take that build spec, that build definition, and push it to the Pyrsia network. So what that is a network of independent build nodes that will independently go and build that software artifact, a container or whatever it may be. When each of these build nodes has come to, or has built the software, are they in agreement? Is each of the builds identical? And if they're not, then of course throw it away. Someone has done something in transit between Git, the source of truth, and that build. So effectively it's a man in the middle for your container. Someone has tampered with that on one of those nodes, or all of them, will throw it away. If they come to an agreement, then that is written to the transparency log on the blockchain. Now, as you probably know, the blockchain is an immutable source of truth. So once your code or your image is there, that's it. It's not changing. And you, there we go, there's me on the bottom corner. I know I can trust that because of Pyrsia's build network, because I've had a consensus across those build nodes that it was true and it was the case. So, demo time. I'll have to see if this is too small. Yes, it is. Too big. How's that? There we go. Okay, so we've installed Pyrsia on this Ubuntu machine. Not much to it, and yeah, we can start the tutorial. Now the first command I'm going to run is Pyrsia ping, and it says command successful. What does that actually mean? Well, we've installed Pyrsia as a daemon on this Ubuntu machine, and I'm now part of the Pyrsia network. So I can ping the network, I can see what's going on, and I can use it. Now, when I installed Pyrsia, we made a change to our Docker daemon file. And all we did was change the registry mirror, try and zoom in a little bit, to pull from localhost. So now I can, as a developer, I interact with Docker exactly as I would. Nothing has changed there. But we're actually pulling from the Pyrsia network now. So if I just show you that I've got nothing in the cache, no such image for Alpine, and I'm going to pull Alpine, and there we are. Alpine's pulled. So as a developer, it's completely transparent, really, to me, that I'm even using Pyrsia, but everything is written into syslog on Linux. So if I cat the syslog and do a bit of fancy grepping, you can see this is the proof that I actually pulled from the network. You can see artifact service storage. You know, there are 0 stored artifacts. I'm going out to fetch the manifest. An artifact is being pulled from the manager with these IDs. So this, to me, is the power of Pyrsia. I'm not having to change the way I work. It's just kind of slotting into my workload and my way of working. Now that that image is I've pulled it, it's in a local cache. What does that mean? Well, obviously, I'm not going to go and pull it every single time, but also, remember, I'm part of the network now. So I am able to distribute this image to other people on the Pyrsia network. Because that's the other element to this. It's a peer-to-peer network. So that's the other powerful part. We're not relying for distribution on centralized nodes. There are the build nodes, which are a network that have to come to a consensus, but then I can distribute this image. Now, what stops me from poisoning my local copy and sending it out to someone else? Well, the blockchain, because everything is verified. If I try and send you a broken copy or a poison copy, it just won't work. You'll get the proper copy. Simple as that. Now, I talked earlier about the transparency log of the blockchain. That's the other. You trust but verify. You don't have to trust anything. You can actually see what's going on, what decisions were made, what was built, who built it, when it was built, etc. And you can have a look at the transparency log or the blockchain for this Alpine image. And when you do an inspect log Docker for that image, you get a JSON blob, effectively, with all of the decisions, all of the meta information about what you received when you did that Docker pull, what was built, by who, the node IDs, the package, etc., etc., etc. So everything is transparent. Now, of course, you can use this information however you like. So you don't even need to trust the Pyrsia network necessarily. You can verify that it is doing its job. So everything is very transparent. So, of course, the next question you've got is, well, that all sounds great, but who runs the build nodes? Who's behind this network? And it's a fair question, because if I'm going to trust a network to pull my images from, I need to trust that network. And as you can see, there are some fairly big names on that list. And actually, anyone can opt to be a build node. Obviously, there is a process involved there that you need to commit to certain agreements and things, because we can't let anyone be a build node, because then, then what happens? But yeah, Docker Hub, Deploy Hub, Huawei, Oracle, big JFrog, big names in the industry. With, of course, is the entire idea is to build this network out for more companies, so it becomes even more decentralized and reliant on 100 companies, not just 6 or 7 or 10. So that's the other key thing about it being a peer-to-peer system, is that more power is better. Woo! So a couple of takeaways. Know your trust boundaries. This is just in general when you're developing software. Your inputs and outputs, obviously, this is just software development 101. Your system boundaries and your dependencies. So it's not just about the code you write, it's about the code you depend upon. Trust but verify, and Pyrsia makes that very, very easy to do. supply chain security is very hard. No one's saying that this is going to solve every problem. No one's saying it's going to be easy, but Pyrsia does help. Pyrsia, as I've said at length, is a peer-to-peer network. The more users we have on this network, the more power the network has and the more decentralized it becomes. And lastly, Pyrsia's new. So if you have ideas, if this talk has sparked any interest, or you think, well, wouldn't it be cool if it did X, Y, or Z, get involved. Raise an issue. Have that conversation. So you can reach out Pyrsia on the CD Foundation Slack. Pyrsia.io is the website. And I promised you that you could find out how to run the demo I just did. killercoder.com/Pyrsia is where you'll find the demo that I just ran. And if you go onto Sked or Shed, you'll be able, I'll upload these slides, and there's a lot of links there to everything I've put, the rule of two, the OWASP threat modeling, the official website, and a link to the demo. So, with that, I'm honored to have the man and lady themselves, the Team Pyrsia, are in the room. So if you have any questions, I'm a fan, but the technical people are here. So any questions on Pyrsia? Not a single one. I did the job. Well done. Awesome.